Hey everyone, so this is day 2 of related rates. So pause and do the do now. All right, so this is a implicit differentiation problem, and then it wants to know what is the value of the second derivative at 3, 0. All right, so there's a few ways to do this. You can divide and make it dy dt equals 2x minus y over x plus 2y. And then do the second derivative using a quotient rule. So d2y dx squared equals, derivative of the top is 2 minus dy dx times the bottom minus the top, derivative of the bottom, all over the bottom squared. Now, if this was just a regular problem, we would then need to substitute in for dy dt, which would be terrible and all that. But because we're just finding a point, what I did was I just figured out, well, what's dy dt at 3, 0? All right, so that's 6 over 3, which is 2. So then I went in and I substituted. So I get 2 minus 2. So that whole thing is just 0. And then, so 0, it doesn't even matter what that is. What is it? It's just 3. Minus, let's see, that's 3 times 1 plus 2 times 2. All over x plus 2y. So that's all over 3 squared. So 9. So this whole thing goes away to 0. So I get 1 plus 4 is 5. So negative 15. Uh-oh, I did something wrong. Over 9. What did I do? Minus, that's not a 3. It should be a 2, right? 2 times 3. Oh, that's a 6. Ugh. So this is 6. So that's 30 over 9. Negative 30 over 9, which is negative 10 over 3. So it's A. All right. I want you to draw a picture and see how much of this you can do. At t equals 0, a car is traveling west at 66 miles an hour towards an intersection 400 feet away. At the same time, a truck is traveling south at 30 miles per hour or 44 feet per second toward the same intersection 250 feet away. How fast are the truck and car approaching each other at t equals 0? So now this one's giving you both miles per hour and feet per second. So which one should we use? Well, since they gave me 400 feet away and 200 feet away, I'm not going to be using that 66 or the 30. Right. So let's draw a picture. So the car is west and the truck is south. Here's my intersection. Oh, the truck is traveling. Okay, so here's my car. Let's see if I can do the car. Hey, look how talented. You know you guys are jealous. So the car is going at 96.8 feet per second. And the truck is traveling south. So here's my truck. I can't do a truck. Clearly it's going the wrong way, but whatever. And that's going this way at 44. 250 feet away. So this distance is 250, and this distance is 400. How fast are they approaching each other? All right, so now we need some kind of formula. So this is, yet again, Pythagorean theorem. You know, this is pretty common. All right, there's my Pythagorean theorem. All right, so let's label these. A, B, C, X, Y, Z, whatever you want to do. I'm going to do X, Y, Z. You know, I'm going to make this one X. I'm going to make this one Y. And this one Z. All right, so we have X, dx, dt, Y, dy, dt, and then Z, dz, dt. All right, so my X, so at t equals 0 to start with. At t equals 0, X is 400, dx dt is 96.8, 250, 44. How fast are the car and truck approaching each other? So that's your dz dt, so that's my question mark. And then I can do Pythagorean theorem to find my z. So let's see, 400 squared plus 250 squared is divided by 100. So 10 root 629. So I just did Pythagorean theorem. I mean, you could honestly, like calculus, we don't care if you simplify, but writing the square root of 62900 is annoying in my opinion. I think it's nicer just to pull out the 100, which is why I did 10 root 629 instead of the square root of 62,900. All right, so now we have x squared plus y squared equals z squared, 2x dx dt plus 2y dy dt equals 2z dz dt. I like to put the little cross on the z's a lot, so I don't think they're 2's. You don't have to, but it's helpful. Now notice none of these have zeros, so we're going to have to actually fill everything in. I think with this one I canceled out all my 2's to make the number smaller. So then 400 times 96.8 plus 250 times 44 equals 10 root 629 times dz dt. So that dz dt equals, let's see, 400 times 96.8 plus 250 times 44. And divide by 10. So I got 4972 divided by the square root of 629. And that's my answer. That's not the perfect square root, 629. No. All right. So that's that answer. So now what would we do if we wanted to do t equals 4? T equals 4 is a little more challenging. I should add a blank page. Okay, so I redid this, I rewrote it. So now if t equals 4, we're no longer at 400 for x. Where are we? We're a lot closer. So if we do 96.8 times 4, and then we have to take that away from the 400. So let's see, 96.8 times 4, subtract that from 400, and we get 12.8. So this is now 12.8. And then 250, same idea. 250 minus 44 times 4. $74. And then we could figure out our dz dt doing the same problem. So we had to figure out how far away from the intersection are they. And then, again, Pythagorean theorem. And then, oh, this one's gross. So this is the square root of 5639.84, question mark. So x dx dt, since we already did it, I'm not going to write it out, dy dt equals z dz dt. So 12.8 times 96.8 plus 74 times 44 equals that crazy square root times dz dt. Let's see, 12.8 times 96.8 plus 74 times 44. So we get 4495.04 divided by that square root of 5639.84. You can get a decimal if you want. You can leave it like that. It's up to you. Depends on the problem. Sometimes I'll find the actual decimal. I think in the textbook they give decimal answers. All right. A 6-foot man walks away from a 15-foot lamppost at 5 feet per second. How fast is his shadow lengthening? So we have our 6-foot man. He's walking away from a lamppost. So here's the lamppost. Right. It's giving off light, right? So the lamp is giving off light and it's hitting his head and creating a shadow. Right. He's walking 5 feet per second. 15, 6. How fast is his shadow lengthening? So they want to know from here to here. Let's call this, if we call this x, what's dx dt? Notice he's walking away at 5 feet per second. So now this one's tricky. I have to look this up a lot of the time. I have trouble remembering how to do this. Because I know, what is it? It should scream out at you something specific. What does it scream out at you? It should scream out at you, I am a proportion, right? We have our big triangle and our little triangle. Right? So I'm going to call this part from here to here, that distance is going to be y. Okay. You can do the whole thing as y, but I feel like it's easier doing it this way, from doing it a few times. All right, so proportion, short side over long side. So the lamppost over the entire bottom. What's the entire bottom? Y plus x equals height of the man over the bottom of his triangle is x, right? So I'm going to cross multiply. 15x equals 6y plus 6x. I can subtract. 9x equals 6y. 3x equals 2y. So notice, there's a lot. This is a really simple problem. It looks so scary, but it actually ends up being really easy. I think it's the setup that's just super confusing. What this part is representing him walking. That change, the dy dt is how fast he's walking, and I think that's what's challenging. Where does that go? Is it it's not the entire distance at the bottom. I always want to say that this whole thing is him walking, but it's not. It's this being changed is his walking. So this is our 5. So then we just take our derivative. 3 dx dt equals 2 dy dt. So 3 dx dt equals 2 times 5. So dx dt equals 10/3. And that's it. It's just a tricky one to set up when you've never seen it. And it takes me a minute to remember how to do it. All right, last one. This one's not so bad. Now that you've practiced a lot, you shouldn't have too much trouble with this. A plane is flying horizontally at 4,000 feet west at a speed of, it's flying west, 700 feet per second. A searchlight under its path tracks it. How fast is the light pivoting when the plane is 1,000 feet east? All right, so here's my light. Giving off a light. The plane is over. I'm not going to draw a plane. I can't draw planes. I'm going to make a plus sign. because I can't draw planes. All right, that's my plane. It's going this way at 700 feet per second. It's 4,000 feet in the air. The light is pivoting. So there's a triangle, right? But unlike the other ones, and it is a right triangle, we're actually not going to be using Pythagorean theorem, because how fast is the light pivoting? What's it asking? It's asking about an angle. That is asking about an angle. So that's a little tricky when it's 1,000 feet. All right. So which trig ratio are we going to use here? Well, it gives me 1,000 and 4,000. It's giving me the opposite and the adjacent. So this is a tan problem. So we're going to do tan of theta equals x over y. Right? So my variables are x, y, and theta. All right, so x is my 1,000. My y is 4,000. I don't know theta, and then we have dx dt. Ugh, of course I wrote it, so it's not going to fit. What's dx dt? 700, but it's getting smaller because it's going that way, so I'm going to say it's negative 700. dy dt, what's dy dt? That's just 0. The height of the plane is not changing. And then d theta dt, and that's actually what we want to know. That's our question mark, right? So we have to figure out theta. I'm actually going to cheat with this one. We don't actually have to find theta. I'm going to show you what I do instead. All right, so take the derivative. What's the derivative of tan? So secant squared of theta, d theta dt, equals. Now, since the derivative of y is 0, y is a constant. This is just x over 4,000. So you don't have to do a quotient rule. A lot of you will do a quotient rule, but you don't have to because the bottom is a constant. It's just dx dt over 4,000. That's it. So now here's what we're going to do. What is secant of theta? Well, one thing we are missing, if we do Pythagorean theorem, we can find our z value. Right? So 1,000 squared plus 4,000 squared. Divided by 10, 100. Oops. So it's 1,000 root 17 is what I got when I simplified it. So cosine of theta, all right, I'm going to do this in blue because I don't want to have to find the angle. So cosine of theta, here's theta, is adjacent over hypotenuse, so 4,000 over 1,000 root 17, which means secant is 1,000 root 17 over 4,000. And then I can cancel out my thousands. So it's root 17 over 4, but then it's secant squared. So this is root 17 over 4 squared. All right, so we get root 17 over 4 squared d theta dt equals, my dx dt was negative 700 over 4,000. So this is 17 over 16. And then I just have to multiply both sides by 16 over 17. All right. So what's that? 4 goes into 16. 4 times. So that's negative 2,800 over 1,700. Okay, and those go away. Negative 28 over 17. Whew. So that's how I do these. I know these tend to be, kids mess these up, but I don't think they're that hard. The trig ones. I mean, if all else fails, if you're using a calculator, you could do, okay, what is theta equal to? Right? Second tan of 1,000 over 4,000, 1/4, is 0.24497. And then like maybe store that into an angle if that makes you happier. You could do that. Right? This is 0.244978. I would just be careful with rounding too much. But that's it. All right, same thing. We already talked about that. Just kind of going through, identify your equation and your variables. Try to make a substitution if you can. Plug into the original to find missing pieces like Pythagorean theorem. And then once you get all the information, this is not the hard part. The setup of the problem is the hard part. So get through that setup. All right, there's your homework. And then again, I want you to finish that worksheet that we started on Monday. All right.